Good morning, everyone. In this video lecture, we're going to talk about query processing in database management system. And actually, I had two topics, query processing and query optimization. So I was in dilemma whether to make a video on query processing or on optimization because two users asked these two different questions. So actually, optimization is part of processing. So in this video lecture, I'm going to cover both. Okay. And first we'll start with query processing, what query processing actually is in Dbms. So as the name suggests, query processing means you're processing a query. So you already know this is an example of query. Select star from employee. So this is a query. Okay. How a system processes this query to produce the result, right? This whole process is called query processing. Fine. So query processing is, there are a lot of activities. Query processing means performing certain activities that will help fetch the result from the database. For example, in this query where you want to select certain data from the relation employee or table employee, relation and table are usually used interchangeably. So relation is a table, right? So query processing consists of different activities that will help fetch the result from the database or help perform an operation on the database. So for example, even if you want to modify a relation, or maybe you want to add some more data into the relation, or maybe delete a record from the relation, right? Delete a record from the relation. So when you write a query, for example, if you are using SQL, you will write a query using commands, syntax, symbol, etc. used in SQL. For example, select star from employee. So we have select command here. The star is a symbol, right? That denotes everything. And employee is name of the relation. So this query means that I want to fetch all the data from the relation employee, right? Now, as a user, you know what it means, but the system or the machine on which you are running this query doesn't know what it means, right? So if you're also watching my other programming videos, you know that in the very first programming lecture, I talked about how we make use of high-level language to write programs, but machine is actually not able to understand because we are using English statements, right? But machine does not understand English. It only understands machine language, that is zeros and ones, right? So same goes here. You as user know what this query means. You know what you want to fetch from the system, what you want to perform, but the system doesn't know that, okay, what you want from the database, right? So this query in English statement with the use of command and symbols, etc., has to be converted into something that matches the internal representation of the query. Okay, what I mean by internal representation, if you remember in 3 schema architecture, we discussed external and internal view, right? So external view, something that user can understand, and then we also had middle view where programmer writes the program or the queries and everything, right? So this query is understood by you, the user, but the internal level, right, the physical level, internally, data is stored in a different form. So there is need to regard those representations to actually fetch the result or perform certain operations on the data. And this whole process is called query processing. And then it also involves optimization. Okay. So this was a brief overview, and I hope you understood the whole process. I hope you understood. Usually when you are query processing is a way to convert high-level expression into physical level implementation. What I mean by that, if you have this query, this is high-level expression, select star from employee, and then it has to be converted into something which can easily map to the internal structure of data, or which can make it easier for the system to perform what user wants it to perform. Okay, and as you can see in this query also, remember this, we will actually come back to this once we start diving deep into this concept. So query processing, as I told you, there are certain activities that you need to perform while processing a query. You don't do that, obviously system does, but let's see what these activities are. So there are three main activities in query processing. We have compilation, optimization, oh my goodness, compilation, optimization. It has to be optimization, I'm really sorry. I'm not sure if I can change it. Let me see if I can. So okay, it has to be optimization. Okay, I'm really sorry for that. This is compilation, optimization, and code generation. So there are three activities in query processing. So first, we're gonna talk about compilation. We'll come to this portion also, but let's first just focus on compilation. Okay, so the process of compilation includes two sub-processes, parsing and translation. Okay, when you have a query, and the components used here are parser and translator. Okay, there are three main steps in query processing: compilation, optimization, and code generation. And there are certain elements or certain components that perform these activities. So we have compiler, and then there are two main other processes, parsing and translation. So parser performs the parsing, and then translator will translate it. And I hope you understand this thing. When I'm saying parser or when I'm saying translator or even compiler, it doesn't mean I have a hardware. There is no device, right? It's just a program. Okay, compiler is just software. What is software? Collection of various programs. So there are different instructions and programs. So it's not a hardware that I'm talking about, right? So when the compilation process starts, there are two main sub-processes, parsing and translation. So parsing means the code is parsed, okay? And this parsing involves working with certain elements of the query. So we are not talking about program here, so I'm gonna say query. So for example, we have this query, select star from employee. So when it is compiled, right, the first step is compilation. So when it is compiled, first it will be parsed. So what that means is there are three steps in parsing. Again, we have lexical analysis, syntactic analysis, and semantic analysis. They all focus on three main things. So first of all, lexical analysis will be performed, and what it does is this whole query will be broken into tokens. Okay, what I mean by tokens, token you can say is the smallest element of a query. Okay, it is the small, if we are talking in terms of programming, it is the smallest element of a program. So in this case, it is the smallest element of a query. So how many tokens are here? 1, 2, 3, 4, and 5, right? So these tokens, again, they have different names. It can be a command, it can be name of the relation. As you see here, we have a symbol also. So all of this, so these are all tokens. Fine. So lexical analysis will break this query into different tokens. Okay, so lexical analysis deals with tokens. So everything is converted into tokens, right? So different, like we are taking one thing at a time. And then comes syntactic analysis. It will check the rules of the query. is this query actually following the rules? So for example, if you're using SQL, there are certain rules that have to be followed, right? There are certain symbols you have to use for certain things. If you wanna fetch data from certain relation, you have to specifically use select command, right? Select statement has to be used. So are these rules being followed? Okay, that will be checked by syntactic analysis. Fine. So yes, we have select in SQL, we have star, we have from, and then this is name of the relation. We are not sure about that, but if it goes select star from, then we obviously know it has to be name of the relation, right? So yes, syntactic analysis will check for that. Then comes semantic analysis. Now semantic analysis will check the meaning of the query. What I mean by that, does this query have a meaning? How can it have a meaning? It will have a meaning if it follows the rules of SQL, which it did, and it also has names, right? Names of relations or names of columns, etc. If the names are actually existing. So for example, when semantic analysis is performed, it will check for the meaning and it will check for this relation. It will check whether this relation actually exists in the database, because if it doesn't, then this query will be meaningless, right? There is no meaning to this query because it will not return any result, right? So meaningless query. So it will check for the name of this relation, whether it is actually existing in the database, right? So that's what semantic analysis does, okay? And once everything is done and lexical analysis is done, syntactic analysis is done, semantic analysis is done, so all the rules are followed, the query has a meaning, then comes translation. And what happens is, because all the tokens make sense now, right? All the tokens have been used in such a way that they follow the rules of SQL. They make a query that has a meaning. So now we can convert these tokens into a different representation that will be used in the coming step, right? So after parsing comes translation. So these tokens are then converted into trees or graphs or even relational expressions. Relational expressions we haven't really talked about, but basically relational expressions use and, or, not, like these kind of operators, right? And for the sake of this video lecture, I'm going to give you a very simple example of a tree. So we had this query select star from employee, but I'm gonna take another query. So let's say we have select name from EMP. So name would be the name of the column, obviously, and EMP would be name of a relation, right? And then I'm using where clause where ID equals to 7. Okay, now let's construct a tree using the tokens here. So first of all the tokens, remember what all the tokens are. We have, what are all the tokens? We have select, we have name, EMP, from, where, ID equal to, and 7. Okay, after this, semantic analysis, syntactic analysis. Yes, it does follow rules of SQL, and let's just assume that EMP table exists. There is a column called name, and there is also a column where IDs are given, and 7 is one of the IDs. So after this, we need to translate it into the tree. So how we're gonna do that? First we have, let's see, we have commands are, we have select here, we also have from, right? and then where. Okay, so what we're gonna do is this is, let's say, for, okay, I'm not going to use the symbols, I'm just gonna write it like this. So first we have query, right? Now I'm going to create a tree out of it. So how many commands we have? We have 3. So 1, 2 and 3. And what are these commands? We have select, then we have from. When I say commands, you can also say statements. I actually mean keywords. Okay, so they have specific meaning in SQL. So we have select, from and where. Now select goes where, select is actually, and then from, and then where. Okay, so what are we selecting? We are selecting name, from, emp, where we are talking about ID, right? Now, do we have values? Yes, we do. Only one value, that is ID. So we're gonna take just that. Fine. So this is how you will create a token. You will create, you will not create, you can also create, I mean, if you understood how it goes. But this is the translation process. It's gonna convert that query using the tokens and everything into a tree or a graph or a relational expression, whatever. Okay, so this is the main process of compilation, where first parsing happens and then translation happens, and this is the first step. Okay, let me go back to this. Right, so we had compilation. This is how compilation is done. Now let's talk about optimization. And I hope you understand what optimization means. Optimization means the right use of memory. You know, optimization means, for example, let's suppose you want to go from one state to another state. Okay, now you will have a lot of options. You can go via train, plane, bus, car, right? But what will be the optimized way? Like, how can you save more time, right? So you have to decide on that. Okay, so that's what optimization is. When you have created, so I showed you just this one example of a tree, and if you know how graphs and trees work, usually even in trees we will have this one, if I may, I'll call it a source. Okay, and then there could be one destination, right? Now I'm going with select, from and where. We can also go with select, from and where. So ID, this thing can come here as well. Okay, and we are not talking about binary trees and all of that, but if we take that into consideration, it's going to affect the way memory space is being used. It's going to affect the way we go from the top to the bottom, right? So there are different things that can be taken into consideration to make sure that query is executed with low latency, with less time, and memory is also utilized. Okay, and when we start talking about these things, that's when we talk about optimization. Okay, so in optimization we have two steps: evaluation and choosing the best plan. Evaluation obviously means that once you have like trees and all those structures that we talked about, you will have different forms of these structures. So you need to choose the best one. That can come with evaluation plan. And evaluation plan will definitely depend on the type of language you're using. If you're using SQL, for example, or MySQL, you know, there are different query languages as well. So it will definitely depend on the type of query language you're using, the server and everything else, right? And as I told, there are many paths from source to destination when we talk about trees and all of that. So you need to choose the best one. And then in the same evaluation plan comes algorithms. You can also utilize algorithms to choose the best plan. Okay, so it's just that user only writes the query, and user is not concerned if query was efficient enough or not. Okay, what I mean by that, so this query, we don't know if this is efficient enough or not. Okay, sometimes not using where clause can make the query efficient enough. Sometimes you have to use it so that it is efficient enough. So if you don't have knowledge regarding that, this is the responsibility of optimizer, that the best technique is used for query processing, right? And again, like I told you, there are various components that take care of this. So in optimization also, we have execution engine that takes care of this. Okay, and then optimizer will it will also keep track of memory allocations. It will take memory allocations into consideration while choosing the best plan, and it will pick the optimized evaluation plan. Okay, it will check the best order of subqueries meaning, for example, in this query there are many subqueries as well. So this is select name from emp, this is one query, and then we also have where id equals to 7. So there are subqueries. So this is just one very simple statement. There are a lot of complex statements as well in SQL where there are a lot of subqueries. So optimizer execution engine, they have to take care of that. They have to choose the best order of subqueries. They also have to take into consideration CPU time, number of times the disk has been accessed to fetch data or to perform operations on data, and how many operations are there to be performed, and all of that. Okay, and once it is decided, then the query is executed and result is shown on the screen. Okay, and this is what code execution is, the low level representation of query which is run by the system to bring the result. Once the best plan has been chosen, the code execution is actually that level. It is the lowest level where query is actually represented in the form where machine can understand it and execute it. Okay, so this is the whole process of query processing, how query is actually processed in SQL. And I really hope it made some sense. If it didn't, if there was anything that you that you think is not clear, or maybe I could have made you understand it, even I could have made you understand, like I could have explained in a better way, then please do let me know. And yeah, you're always, basically, if you have any doubt, you can always ask, right? If anything was not clear, you can always ask. So in the next video lecture, I'm actually going to create a program for dictionaries where we'll see how you can have multiple keys in a dictionary. This is one of the questions that I got from a subscriber. Can we have multiple keys? Can we have multiple keys in a dictionary? Because dictionary works with keys and pairs. So we'll talk about that in the next video lecture. For this lecture, this is it. For any doubts, for any queries, anything, if you have any doubt or topic you want me to cover, feel free to comment in the comment section below. I'll see you in the next video lecture. Till then, take care.